So for lesson 5.1, we have the uniform circular motion and tangential velocity. Introduction. The first law of motion tells us that any object that moves with a constant velocity will continue its motion unless it is acted upon by an outside force. In the case of objects in a circular motion, the object in motion will simply head forward in a straight line without an external force which is directed towards the center. This force is called the centripetal force and is responsible for the motion of objects traversing a circular path, such as the turntable in the photo above. So, traversing means travel across or move something back and forth. In this lesson, you will be able to identify whether a circular motion is uniform or not, as well as to calculate the tangential and rotational speeds undertaken by the object in uniform circular motion. We have the next slide, which is the learning objectives. In this lesson, you should be able to do the following: explain uniform circular motion, distinguish uniform from non-uniform circular motion, solve problems related to the tangential speed of objects in uniform circular motion. Next slide. Observe that in the figure 5.1.2, the vector for acceleration is perpendicular to the circular path and is directed towards its center. Perpendicular means it is an angle of 90 degrees to a given line, plane, or surface. The car moving with uniform circular motion has constant speed and an acceleration that is directed in the direction of the circular path's center. This explains why a change in the velocity's direction is possible without a change in the speed. Next, we have the uniform circular motion calculations. Remember that the direction of the acceleration at any given point is along the circular path's radius and toward the circle's center. As shown in the figure 5.1.3, it is for this reason that uniform circular motion is also sometimes referred to as centripetal acceleration. This is signified by the subscript rad in the variable a rad. The magnitude of acceleration of any given object that undergoes uniform circular motion is mathematically expressed as follows. So this is one of the formulas that we are going to utilize later on when examples are shown. It is where a rad is the magnitude of acceleration of an object in uniform circular motion, v squared is the speed of the object, and the r is the radius of the circular path taken by the object. So another way, or an alternative for this formula, is to determine the magnitude of an object's acceleration in uniform circular motion is to take into consideration the motion's time, or time for one revolution. This refers to the duration time which an object has taken to accomplish an entire trip around the circular path, and is related to an object's acceleration as follows. So this as well is going to be utilized later on when examples are shown. It is where a rad is the magnitude of acceleration of an object in uniform circular motion, r is the radius of the circular path, and t is the period of motion. So next we have the tangential velocity. The motion of an object traveling in a circular path is signified by its rotational or angular speed, or the number of revolutions per unit of time, commonly expressed in the terms of RPM, rotations-revolutions per minute, or radians per second, also known as rad-s. This is contrasted with the linear speed, because if the rotational angular speed is the motion of an object traveling in a circular path and is signified by the number of revolutions per minute per unit of time, linear speed on the other hand refers to the distance an object has covered in a unit of time and is measured in meters per second, or m-s. In the case of uniform circular motion, an object moving on the outside edge of a circular path will have traveled a greater distance than an object moving closer to the center, as both of them complete their rotation as shown in figure 5.1.4. So apologies for not showing you the figure 5.1.4, but you can use your study guide to see this figure. The object at the edge has higher linear speed because at the same amount of time it traveled a longer distance, since the circular path that is traveling around has higher circumference compared to the object near the center. This line or speed of an object in motion along a circular path is referred to as tangential speed or tangential velocity if a direction is assigned to it. Next, we have calculating tangential speed. An object's tangential speed depends on its radial distance, or r, from the axis and is measured by this. So this formula in the equation 5.1.3 will also be utilized later on when examples are shown, where vt is the object's tangential speed, r is the radial distance of the object from the axis, and is the object's rotational speed. So before we move on to our examples, remember that rotational speed, signified by the Greek letter omega, though it may seem like a double to you, but it is how you say the term omega, refers to the number of revolutions completed by an object around its circular path. Tangential speed, on the other hand, refers to the speed of an object along its circular path.
So, nata example diri, an electric drill whirls at 60 radian per second. If the drill has a radius of 0.002 meter, what is the tangential speed of a point on the surface of the electric drill's bit? So, ang ato ang pangitaon diri kay ang iyahang tangential speed. Ang ato ang gamiton na formula is Vt tangential speed is equals to R, which is radius times W, ang rational speed. So, since given naman ang radius 0.002 meter og ang rational speed ang 60 rad per second. Ang atuan na lang buhaton ani karon is atuan na lang ni siyang isolve. So, Vt is equals to R times W. R radius is 0.002 meter times 60 rad per second. So, ato na siyang isolve 0.002 times 60 is equals to siya 0.12 meter per second. So, basig matingala mo nganong nawala ang rad kay ano na siya 1 meter per meter is equivalent to 1 rad or rad. So, automatically ma-cancel out na ni siya, mawala na ni siya kay 1 meter per meter man. And mabili na lang. So, sa ato ang try it sa AC, determine the tangential speed of a wheel with a radius of 0.5 meter as it spins with a rotational speed of 58.75 radian per second. Pareho ganina nga, given naman ang ato ang radius o ang rotational speed, all we have to do is isolve na lang siya. So, given is radius is 0.5 meter and then ang ato ang rational speed is 58.75 radian per second. So, tuan na ni siyang isolve. Vt is equals to radius times rational speed. So 0.5 meter times 58.75 radian per second. So ato ana siyang ikuan 0.5 times 58.75 is equals to 29 point, so i-round off man na siya no, 29.38 meter per second. So same ganina, nawala ang radian because 1 meter per meter is equals to 1 radian or radian. So, so ma-cancel out na ni siya automatically, and then mabili na lang ni siyang meter, so mahimo ni siyang meter per second. So sa ato ang next example, a propeller with a diameter of 2.5 meters spins at 1.91 revolutions per second. Determine the rotational speed of the propeller in radians per second and the tangential speed of a point on its surface. So kay ang given man nato is diameter and revolutions per second. So need na to na siya i-convert ang diameter to radius and then ang revolutions per second to radians per second. So first, ang una na to i-convert is ang diameter to radius. So ang ato ang formula ani is R is equals D over 2. So basig matingala mo og asa ni gikan. So ang katunga sa circle is diameter. So para mahimo siya nga radius, kinahanglan nato siya i-divide sa 2. Sa 2. So, atoan na ni siyang isolve. Ang value sa diameter diri is 2.5 meters over 2. So, mahimo na siyang 2.5 divided by 2 is equals to 1.25 meters. So, mauna ni siya ang atoang radius. The next one is ang atoang revolutions per second. I-convert na to siya into radians per second. So, ang formula na to ani is W equals 1.91 revolutions per second times 2 pi rad over 1 revolution. Mauna ni siya ang constant na formula para ma-convert ang revolutions per second to rad. So, ang unahon nato ani, since kay duha man ang revolution, so ma-cancel out na ni siya. And then, ang unahon nato ani is i-times sa nato ang 2 ug ang pi. 2 pi is equals to 6.28 and so on. Divided by 1, 6.28. So, kay dili man nato siya ma-round off kay below 5 man ang nagsunod sa hundreds na number. So, mahimo na siyang 6.28. So, mahimo ni siyang 1.91 seconds times 6.28 rad. So, kung i-solve na to ni siya, 1.91 times 6.28 lah. Ano man eh? So, 2 So, 2 pi is equals to 6.28 divided by 1. 6.28 times 1.91 is equals to 12.0. 12.0 rad per seconds. So, mauna ni siya ang ato ang rotational speed. So, kay nakuha naman nato ang ato ang radius na 1.25 meters o ang ato ang rotational speed na 12.0 radians per second. So, atoan na lang ni siyang isolve para makuha nato ang iyahang tangential speed. So, Vt is equals to Rw. Mahimo ni siyang 1.25 meters times 12.0 radians per second. Ito na siyang isolve. So, ito na siyang isolve. 1.25 times 12.0 is equals to 15. Cancel out na ni siya. So, siyang 15 meter per second. So, maunad ni siya ang atoang tangential speed. So, sa atoang try it, a weather vane with a diameter of 2.5 meters spins at 2.25 revolutions per second. Determine the rotational speed of the vane in radians per second and the tangential speed of a point on its surface. So, same ganina kay ang given raman kay ang diameter ug ang revolutions per second. So, need na to sila i-convert. So, first, ato ang i-convert ang diameter into radius. So, R is equals to D over 2. So, ang ihang diameter din given is 2.5 over 2. So, same raman na siya sa ganina. So, may mo ni siyang 1.25 meters. So, mauna ni ang ato ang radius nakuha na nato. So, next is ang ato ang revolutions per second. Need na to siya i-convert into radians per second. So, W is equals to 2.25 revolutions per second times 2 pi rad over 1 revolution. So, kay ma-cancel out na ni siya. And then, same atong gibuhat na to kanina. 2 pi is equals to divide 1 times 2.25. So, mahimo ni siyang 14.14. 14.14 radians per second. So, mauna ni siya ang ato ang rotational speed. Na-convert naman nato siya to radians per second. So, karon nakuha naman nato ang iyang radius na 1.25 meters ug ang iyang rotational speed na 14.14 radians per second. Atoan na lang na siyang isolve para makuha nato ang iyang tangential speed. So, Vt is equals to radius times rotational speed. So, 1.25 m times 14.14 radians per second. So, atoan na siyang isolve. 1.25 times 14.14 is equals to, so mahimo na siyang 17.68. 17.68. Cancel out naman ni siya meter per second. Mauna ni siya ang atuang tangential speed. Last example is, a beetle is found 0.075 meter from the center of a spinning car wheel. At this position, the tangential speed of the wheel is 7.50 meter per second. If the wheel has a radius of 0.225 meters, calculate the tangential speed on the car wheel's outer edge. So, kay ang given man kay ang iyahang radius ug ang tangential speed, pasabot pa ang need na to pangitaon kay iyahang rotational speed. So, ang ato ang gamiton ana nga formula kay, instead of Vt is equals to R times W, ang ato ang gamiton kay W is equals to Vt over R. So, rotational speed is equals to tangential speed over radius. So, sa given, kay ang tangential speed niya kay 7.50 meter per second over sa radius na 0.075 meters. So, ang answer ani kay 7.50 divided by 0.075 is equals to 100. So, kay duha man ang iyahang meter. So pasabot pa mahimo na ni siyang mahimo na ni siyang radians. So ang answer man ato kay 100 radians per second. So mao na ni siya ang ato ang rotational speed. So kay na kuha naman nato ang iyahang rotational speed. So magamit na nato siya para makalculate ang tangential speed sa outer edge sa car's wheel. So itong ganina na para makuha ang tangential speeds is Vt is equals to R times W. Ang radius na ikaduha kay 0.225 meters times pila tong ganina 100 radians per second. So kay mawala na ni siya. Tuan na ni siyang 0.225 times 100 is equals to 22.5 meter per second. So mauna na siya ang tangential speed sa outer edge sa car's wheel. So sa last na to na try it, a rotating turntable with a radius of 0.195 meters has a tangential speed of 1.25 meter per second at a point of 0.013 meter from its center. Calculate the turntable's tangential speed on its outer edge. So, sama ganina, need na to pangitaon ang rotational speed gamit ang mga given kay para makalculate na to ang turntable's tangential speed on its outer edge. So, first, kay W is equals to Vt over R. So, ang tangential speed is 1.25 meter per second over radius na 0.013 meters. So, ato ni siyang isolve. 1.25 divided by 0.013 is equals to 96.15 radians per second. So mauna na siya ang ato ang rotational speed. So karon kay nakuha naman nato ang iyang rotational speed, ma-solve na nato ang tangential speed niya sa outer edge. So Vt is equals to Rw. So himo na ni siyang ang sa study guide, ang naa sa study guide is WRs. Pero actually, pwede raman nimo na siya baliktaron kay same raman gihapon siya answer. So, kung sa RW kay 0.195 meter times 96.15 radians per second. Mawala na ning radians. So, ang answer ani kay 0.9195 times 96.15. So, mahimo ni siyang 18.75. So, mahimo na ni siyang 18.75 meter per second. So, mauna ni siya ang tangential speed sa outer edge sa turntable.